All right, let's take a look at topic number 27, properties of logarithm. Some of these properties here look very similar to some of the exponent property, but they're not still not quite the same. All right. So the first properties of logarithm is something called the product rules. Product rule for logarithm says if you have a logarithm with a base a of m times n. Okay, so you got two things being multiplied. Okay, this is a single term. This is a single term. All right. So then what you can do is expand this into two separate terms. So if you're taking a logarithm of some sort of multiplication, then you can actually say this is a log with a base a of m plus log with a base a of n. You kind of just split them up into two separate terms with the addition sign. All right, product rule will actually translate into addition of two separate terms. So if I want to expand log with the base a of 3x, 3x means 3 times x, then I can say this is log with the base a of 3 plus the multiplication become plus log with the base a of x. There you go. That's how we expand them. Quotient rule. All right. If I take a logarithm with a base a of something divided by something, division is quotient rule, m over n, then this division will become subtraction. And it's always take the top, subtract the bottom. So log with the base a of 3 over x, right? This division will translate into subtraction. So that will be log with the base a of my top 3 minus log with a base a of x. Okay, we expand one term to multiple terms. Power rule. If I take a log with some sort of base a of m, and that m has some sort of exponent power, all I need to do is move the power, bring the power down to the front of the logarithm. So that becomes p times log with the base a of m. All right, bring the exponent, bring the power to the front. So that should give me 3 times log with the base a of x. Okay, if you got exponent, you can bring it down. All right, product, quotient, and power rule. All right, so expand the following logarithm expressions, okay, using combination of the three rules. So which one do I apply first? Which one do I apply first? Well, normally problem look like this is probably do the quotient rule first, okay? Because the x squared y to the third goes together on the top, right? So you got to separate your top from the bottom. So if I want to expand this, I need to see, okay, here is a division that will give me a subtraction here in a minute. So far, all right, I should have with a log with a base 2 of the top x squared y to the third minus log with a base 2. Okay, remember now, it's log, so all these terms should be log with the base 2 of z to the 5th power. Okay, so now I have two terms. Okay, but the first term is the log with the base 2 of something multiplied something. So x squared y times y to the third. That multiplication will give me another addition. Separate between those two. So I should have log with the base 2 of x squared plus log with the base 2 of y to the third minus log with the base 2 of z to the fifth. And the last thing I do, once I split them up, the last thing I do is bring the exponent down. Okay, so a lot of times students will actually bring the exponent down first. Okay, they kind of know all these exponent will come to the front of each term, of each logarithm terms. So my final answer should be 2 times log with the base 2 of x plus 3 times log with the base 2 of y minus 5 times log with the base 2 of z. There you go. That's how we expand them into 3 terms. Let's try another one, okay? Again, the numerator is only having one factor here. So I'm going to divide up the top and the bottom. So this should be log with the base 2 of x minus, right? This division means minus log with the base 2 of x minus 3, x plus 2, okay? So make sure you understand this. This is actually log with the base 2 of these two things multiplied together, okay? I just didn't use a bracket just now. I should, but I didn't. So technically both factor x minus 3, x plus 2 together go with that logarithm. This is not two separate factors. This is not two separate things. These two, both of them go with the log with the base 2. All right. So there's really not, the only thing I can do here is, okay, x minus 3 times x plus 2, there's a multiplication right here. So I can actually split them, right? I can actually split them again. But this is tricky. This multiplication should translate into addition. Okay, a lot of people say this is the answer, but this is actually wrong. Because if you think about it, this subtraction is the same as the division, right? This is the same as that. But you gotta be very careful. These last two terms actually was actually in the denominator. So right now, this thing actually looks like, by having a plus sign right here, literally, this thing is actually saying log with the base 2 of x divided by x minus 3. Plus means times x plus 2. If I actually condense them back, it actually means this. So that actually put the x plus 2 on the numerator, not belong to the denominator. So remember, these guys were all together, right? So even though this is a multiplication is become a plus sign, but in order for this last term to go back to denominator, this actually need to be a negative sign, because technically, if I expand the log with base 2 of this times that, it give me this. I do agree. But if you actually distribute this negative sign in front of the bracket, that actually make the last term also a negative. That is actually the reason why. Okay. Be very careful. Be very careful. This is a little bit tricky. So by looking at this, you can see, all right, the last two terms, if I factor out a negative, then you will go back to look something like the previous line. Then if it look like the previous line, then I can actually work my way back to the original condensed version. All right, this is a very interesting problem. It's a natural log of these three terms, okay? These are three separate terms inside. We can only expand them if they are multiplying. So right now, these are not multiplying. So to make these three terms multiplying, I can actually factor this trinomial in here. So let me do that on the side. I can factor a 2 between these three terms. So that gives me 2 times x squared minus 15x plus, let's see, 112 divided by 2. That will be 56. Okay. So if I factor this, that's x and x, 56, 7 times 8, both is negative, right? Because there's negative 15 in the middle. So this is actually a natural log of 2 times x minus 7, x minus 8. All right, so now I have two multiplication here. So when I expand them, remember natural log is also logarithm. So all the property here applies. This is going to become natural log of 2 plus this multiplication become plus natural log of x minus 7 plus that multiplication become plus natural log of x minus 8. There you go. All right. So these are expanding them. Let's condense them together. Okay, let's condense them. So the way how we condense them is start out with the exponents. Okay, remember the power rule. We move those exponents to the front of each, to the front of the logarithm. So the first thing you do is actually bring those back up to the exponent. So this 3 need to go back up. This 2 need to go back up. All right, so when you condense them, you basically do everything we just did in reverse. So now that should be log with the base 2 of x over 5 whole thing squared minus log with the base 2 of 1 over z whole thing squared. That's not squared. That's to the third power. Excuse me. All right. Now, with that subtraction sign there, that tell me this will be on the top. 1 over z squared will be in the denominator. So now condense back to a single logarithm. That will be log with the base 2 of x over 5 to the third power over 1 over z whole thing to the second power. Okay, from here I can simplify. From here I can simplify it. I'm gonna do this on the side. Okay, x over 5 whole thing to the third is x to the third over 5 to the third, which will give me x to the third over 125. That's the top. The bottom is 1 over z whole thing squared. So that's 1 squared over z squared. So what we got ourselves here right now is log with a base 2 of this, which is a complex fraction. So now I can divide them. Okay, so division, so the top divided by the bottom, division of a fraction means times the reciprocal. So hold on to your first fraction times the reciprocal. So that means we will flip the z to the third back to the top. So now the final answer is actually log with the base 2 of x to the third z. Hold on a minute, make sure I measure my z squared. God, I keep on saying to the third z squared. Z squared over 125. All right, that's how we actually condense it and simplify what we condensed. All right, this one is very interesting. All right, I'm gonna go ahead and move the exponent up, then I'm gonna ask you a question real quick. Log with base 5 of x to the third y squared whole thing to the fourth plus log with the base 5 to the 1 over y whole thing to the second minus log with the base 5 of y to the fifth power, right? All these go back up. All right, be very careful. If you look at this problem versus this one we did earlier, okay, very tricky because this one right here turns out that last sign become negative, indicated the last two term belong together, okay, and what they're log of actually went back to the denominator. That was a tricky one. But here, does this term should go with the last term or the first term? This middle term, I know it's positive, okay? It's positive. It should go with what it should go with the last term. So they will all be in the bottom, happy ever after in the bottom, or it should go with the first term, which will actually establish on the top. Happily ever after on the numerator. This is a tricky one. The 2 minus earlier told me that, hey, the middle term belonged to the back side, okay? Because mathematically speaking, we're supposed to look at this expression from left to the right. So that means the first thing we establish is this plus sign. The first thing you should see is this plus sign. Because this plus sign tell you that, hey, these two should go together. And you get yourself, if you make these two go together, that should be log with the base 5 of x to the third y squared, whole thing to the fourth power, 1 over y squared, right? It should go, if they go together, plus sign become multiplication, right? Then minus your log with the base 5. Now you got two terms. You have three. If you condense the first two, you look like this. Okay, I didn't mean to put them so high. Now this minus sign tell you that this would divide by that. So that's log with the base 5 of all this over y to the fifth power. Okay, that is actually how we actually do it. Now I just got to simplify all this mess. Okay, if I use the power rule for the exponents, then I'm gonna do this on the side. Okay, then I should have x to the 12, y to the 8 times 1 over 1 squared is still 1, right? Over y to the second, whole thing over y to the 25. All right, all these things up here. I got 8y on top, 2y in the bottom. When they canceled out, I should only have 6y on the top over y to the 25 power. Now, once those two got reduced, canceled out, now I can actually take a look. Okay, y to the 6 on the top, y to the 25 in the bottom. So when all those exponents canceled out, that should leave me with 19y in the bottom. So my final answer is actually log with the base 5 of x to the 12 over y to the 19 power. There you go. Okay, a little bit of canceling there. All right, this one only got two terms. So the subtraction sign telling me that x minus 2 is going to be on top, x squared minus 4 in the bottom. So this is going to be log of x minus 2. I'm going to still keep it in the parenthesis for a reason, over x squared minus 4. Okay, if I keep it in the parenthesis, I was hoping you can see that, hey, this x squared minus 4 is a difference of square. So I can actually factor that denominator into x plus 2 times x minus 2. So if I keep them all in the parentheses, then you can see that, hey, this is one term over one term. So I can actually cancel out the x minus 2's. So I end up with log of 1 on the top now over x plus 2 in the bottom. That's my answer. Let's take a look at this example. E to the 7 minus 3 natural log of x minus 2 times natural log of y. All right. So we do need to condense. We do need to condense because I do have natural log involved on the exponent. Okay. So the steps are as follows. Factor out the greatest common factor between the two natural log terms on the exponents. Okay. You see the two natural log term up here? Their greatest common factor is actually -1 because both the terms are negative. So if I factor out a negative, right, between those two terms, then that should give me e to the 7 minus 3 times natural log of x plus 2 times natural log of y. All right. Apply the power rule for logarithm. Okay. Apply the power rule for logarithm on the two natural log terms. So again, I'm looking at in here. The power rule for logarithm is saying the 3 and the 2 need to go back up on the exponents. So that's e to the 7 minus natural log of x to the third plus natural log y to the second power. Okay, remember they're all on the exponents. Okay, so when you do this problem on the homework, make sure all this thing you type in is on the exponent, not right next to the e. Now we're going to apply the product rule for the logarithm. So the product rule for the logarithm is referring to, okay, here's a plus sign. So we need to condense those two natural log. So that will give me e to the 7 minus natural log of x to the third times y squared. All right. So from that answer, now we're going to apply the quotient rule for the exponents. Quotient rule for the exponents. Well, what does that mean? This is where this problem is quite confusing. The quotient rule that where we learn for the exponent is if you have a base a to the n power over same base to a different power. When the base are the same and the base are dividing, what we normally do is we subtract their exponents, right? And that's exactly what we have right now. Right now, what we are having is I got two exponents being subtracted. 7 and this natural log of x to the third y to the y squared is being subtracted. So we need to go from this part back to this part. So the 7 went first. So that means the 7 is actually going to be on the numerator. So your base is E. Your base is E. So that's E to the 7. This subtraction sign is your division. All right. And then E to the natural log of x to the third y squared. Okay. This subtraction is translated back into the division for the exponents. Okay. Now what we can do is we can actually cancel out the base e with the natural log. So the e and the natural log can cancel out. So all I end up with is e to the 7 on the numerator over, okay, x to the third y squared. That's the answer. Because remember earlier there was a property back in topic 26 talking about if you have e to the natural log of x, the answer is equal to x because these kind of canceled out. So all you have left is whatever the exponent is. Okay. All right. So let's take a look. Let's take a look at your homework. Your homework is almost look exactly the same as the one I just did, except there's a little bit difference here. It's almost the same, I think. Ooh, I messed up here. I need to change this. I will go back in and change this. This is supposed to be, let me make sure my signs are correct. I copy and pasted, but I didn't change it. So this problem, let me double check and make sure I I'm gonna tell you correctly. Uh, Give me one split second. There's not much of a difference, but just slightly. Okay. So it's actually, so I would change this part after class. E to the 8, I want it to be 8 minus 4 times natural log of x. And this is where the difference is. Plus 3 times natural log of y. Okay, that is this sign, this plus sign is what the difference is. All right, so let me help you out here. Factor out the greatest common factor between the two natural log terms on the exponents. So if you actually look at these two natural log terms on the exponents, there's actually no greatest common factor other than 1. But what you can actually do is factor out a -1. Because if you look at my problem and look at my hints, okay, I actually want you to factor out a -1. So if you factor out a -1, that will be e to the 8 minus 4 times natural log of x. This plus sign becomes minus 3 times natural log of y. Okay, so all this is on the exponents. Number 2, apply the power rule. Okay, no problem. Apply the power rule. And then number 3, apply the quotient rule for logarithm. This is actually not quotient rule because this is actually a subtraction. Okay, that subtraction becomes dividing. All right, that's the only biggest difference. So now, once you got this answer in number 3, apply the quotient rule for exponents. So that we're referring to right here. So just like I showed you earlier, that quotient rule for exponent, you got your exponents being is subtracting, right? So your base e is to the 8 should be on the numerator. Your base e to whatever this is should be in the denominator. Number 5, cancel out the e and the natural log, cancel it out. So now you end up with e to the 8 on the top over whatever this part is. Now I would need, so step number 6, I want you to take e to the 8. For number 6, I want you to take e to the 8 and divide it by your x, whatever that is, over y, whatever it is. Because once you divide, division of a fraction means times the reciprocal. That's the reason why the hint is trying to tell you that, hey, this this final answer is going to end up to be e to the 8 over 1 times the reciprocal that will make the y to the top, x come down to the bottom. Okay, so now if you multiply them, you end up with the final answer. Okay, so I will make sure I go ahead and fix that. I'll make sure I go ahead and fix this before you start your homework. So that the key difference is that sign right there. That's a plus sign. So when you factor out a -1, okay, the 4 become positive natural log of x, but this 3 natural log of y becomes negative term. All right, so just showing you some of these properties of logarithm and how we can use those properties to expand our logarithm expression or condense them.